Welcome. This is the fourth webinar we're doing with LLMOps.Space. As a reminder, I said it to those of you that joined a bit, couple in the last couple of minutes, but questions not over here in the Discord. I'll be handling the questions and passing them on to Eugene and when it's relevant. So what we're going to be talking about is advanced RAG, chunking, embeddings, vector databases. There's a lot to cover as always, but we're also trying to keep the sessions at least a bit on the shorter side. So let's talk about a bit about what we're going to talk about. So this is the link to the Discord. It's pretty easy, LLMOps.Space/Discord within general chat. And feel free to ask at any phase, and I'll try to manage it so that we join the questions that we're asking kind of the same thing, and also that we leave some space for other ones. For some of the rarer ones, and not everything can necessarily, some of them might be left out, but we'll try to answer whatever isn't answered during the session and offline within the Discord. So about the LLMOps.Space, so it's a global community for LLM practitioners. We have folks from pretty much all the major countries that in the world, and we just grew to around 1,800 community members. The community is a bit different than some other classic communities that and the fact that the data, the content, so forth is pretty much curated. And the idea is we have all sorts of discussions happening within the Discord, but then we also have a website that just has all sorts of lists that are being updated in various different fields. And we're going to have events that are also special around startups, special programs that startups are announcing, launches and so forth, and not only general education contents, kind of like we're having now. So this is the first list we released, the products and the companies in the space. You can see Zilliz is over here now. That's what we're focusing on in this event. But there's quite a lot going on. I think each of the major components here, we'd want to have at least one session that's kind of talking about what we're doing here, and probably multiple, where the idea is, to have a pretty thorough mapping. So if you think there's anything significant that's missing here, then please let me know, me or another moderator. A bit about the agenda today. So we're going to have intro to advanced RAG concepts, chunking, embeddings, and enhancing the performance of RAG models, and issues that have to do with picking the right vector database for your specific use case. So I'm really happy to have Yujian here. Yujian began his software career at IBM after winning a couple of ACL contests twice in a row. Background, like I think a lot of us, in machine learning with a couple of publications. And I think the first significant step in necessarily not the first one, because there was first IBM, but the first significant role that he did was in after the internship was in Amazon with a number of meaningful projects, and now he's been in a couple of startups. Most recently, and the one that he's speaking of now is developer advocate, developer relations at Zilliz. And me, you might know me by now if you've been at previous events, but basically I'm moderating this LLMOps.Space, and what I do with most of my time as CEO of DeepChecks. At DeepChecks, we're building continuous validation of LLMs and AI. So that means all sorts of tools and systems that you're building with some of the other tools and techniques we'll be discussing here. So we continuously validate them and make sure they're working well. We haven't yet released to GA what we're working on that has to do with LLMs, but hopefully we'll soon. In the meantime, feel free to reach out if you want to kind of see more, hear more. But that's a bit about what I'm doing in the day-to-day. And let's get back to LLMOps.Space. So first of all, you can sign up for the next event. We'll send the link here. The next event is in 10 days, November 16th. It has to do with AI LLM security, best practices that have to do with a lot of different phases. I'll be hosting Itamar Golan, that's co-founder and CEO of a startup that's fairly new in this space, but working on some exciting stuff. And if you or any of your colleagues are interested in speaking at future events, then feel free to join here. So yeah, let's move over and take the stage.
Cool. Thank you. Let me get my screen up. Share screen. Cool. Everybody can see this, right? Screen share is loading. Participants. Okay. Hey guys, so my name is Yujian. I'm going to be talking about chunking, embeddings, and vector databases. And so here's a little bit about me. I have a little QR code here you can scan if you would like to ask me any questions on LinkedIn. You can feel free to follow or connect. I'm currently a developer advocate at Zilliz. As Phil was saying, I started my career at IBM and did some research, published some papers, worked at Amazon for a while, and now I work in startups. Zilliz is a company that is focused on handling unstructured data at scale, and so that's why we build the vector database Milvus. Milvus is the only distributed system vector database, and some other projects that you might want to know are Vector Database Benchmark, which lets you benchmark some vector databases, and GPT Cache, which lets you do cost optimization via semantic caching in production. Today, we're going to cover 4 things. So first, I'm going to give a very quick overview of why we even do RAG. And then we're going to look at some chunking considerations, walk through an example, and we're talking about embedding models and strategies, and then I'll walk through some vector database considerations. So RAG overview. Basic idea of RAG is you want to use your data with a large language model. So large language models usually don't have access to your data, and the 2 ways that people think about doing this are RAG and fine-tuning. And I've titled this slide RAG versus fine-tuning, but I just want you guys to know that you can actually use these things together. So RAG basically looks like this. You put your data into a vector database like Milvus, and then the query comes to the LLM, and the LLM talks to the vector database, and then gives you a query, your query response back. The primary use case for these kinds of things are factual recall, because you can force data injection, which is the next thing, force data injection, and then cost optimization, because using this at scale is much, much cheaper than, let's say, training your own model. And then we'll talk about fine-tuning just a little bit. Fine-tuning has its use cases. Fine-tuning is, oops, this is the wrong slide, but fine-tuning is basically you put your data into an LLM and it trains into a new LLM, and then you come to the query and the query talks to the new LLM and you get your response from that. And the primary use case for fine-tuning is style transfer. You can basically tell the LLM that you want it to act like let's say, we train it on Philip's data and we want the LLM to act like Philip. Okay, so the takeaway here is you can use RAG to force the LLM to work with your data by injecting it via a vector database like Milvus or Zilliz. Okay, now let's talk about chunking. Chunking is quite an interesting category that isn't fully solved yet. People are really doing a lot of experimentation around this still. So we'll talk about things like chunk size, chunk overlap, and character splitters. These are probably the 3 primary concerns in chunking. And so chunk size is the size of your chunks, the number of characters in it. Chunk overlap is the overlap between chunks. This is how you preserve context between different chunks. If you are looking through a large document, you want to have some overlap so that you know what's going on between the chunks. And there's character splitters. And character splitters are an addition to the chunking, which allows you to say, we're going to look at specific characters, such as sets of 2 new lines, then we're going to split on that. And so that's what these are. So chunking size is the size of your chunk. Chunk overlap is how much overlap there is between chunks. And the character splitters are specific characters you can use to split your chunks on. Okay, so the number 1 concern when people come to me and they ask me,
just one second, Yujian. Just because we're getting started kind of now, so as we're talking, I'm gonna put a poll. We're gonna have a couple of polls here. So
okay.
The first one, just to kind of get to know kind of who's listening and what's up. Then I'm gonna ask what's the main use case that you're working on. So you're getting a use case now. Feel free to continue in the meantime, and as you go. We'll kind of see where it goes, and I'll end the poll when we want to show it in a couple of slides. So,
Okay.
So the answers are RAGs, summarization, content generation, search, and others. In the meantime, I can see that RAG is the most popular, which is not so surprising, both because the talk is about with that focus, and also just see it more in the market and with different companies. But so keep on for a couple of slides, and I'll end the poll soon.
Okay. So yeah, how does your data look? This is the main concern when it comes to doing your chunking. People always ask me, oh, how should I chunk my data? How should I split it up? Well, it depends on what your data looks like. So here I've shown 3 examples of types of data. This is a very, very abstract representation of what your data, what your text might look like. In conversation data, maybe your text looks like this. There's 1 line at a time. People are sending kind of short one-line things. And with conversation data, character splitters are probably important for you. You probably have some characters that split based on the end of everybody's sentence. And you probably also want to think about it in terms of like, okay, well, how long is one sentence really going to be? 64 characters, 128 characters, something like that. And then you go to documentation data. Documentation data is typically more chunky kind of looking like data, right? It's just like, hey, here's like a bunch of information. It's a big paragraph, and then there's another big paragraph, and so on and so on. So with documentation data, you really want to take in consideration not just your chunk size, but also your chunk overlap. So in chunk overlap, chunk overlap helps you preserve context between two different chunks, and that becomes really important in your documentation data because it is very likely that you are not going to take the entire document or maybe even half the document and put it into one vector. That's not going to be very useful for you. So you're going to want a way to maintain that you have some semantic meaning in your chunks, and B, also maintain the relationships between your chunks so you can understand where that context is from. And then the third
just maybe it's worth saying some example here. I think like in general, just if you're talking to a human and you ask them, tell me some, give me some nuances that have to do with questions I'm asking within, let's just take documentation of some company. Let's say we go to Zilliz documentation and try to learn. So some questions are answered better with a sentence, right? If you give the exact sentence, it's much better. For some of them, you need like a paragraph to kind of summarize it. So not everything is technical. Some of it is like the nuances. I'm sure you're going to touch that soon, kind of as we go on. But a big part of the chunking strategy is the technical aspect of preserving the context. But part of it is definitely like what would a human do in that case?
Yes. And I'm going to touch briefly on that in the example as well. And then the third example that I have on what your data looks like is maybe you're in a lecture or a QA session where you're going to have different sized semantic chunks, basically. So if you were to think about this as if you were, as if you were a human, you would think, okay, well, there's going to be questions and there's going to be answers. And then perhaps there's also going to be portions where there's a lecturer who just kind of talks for a while. And so in these cases, you're going to think about, how do I want to split this up so that it makes sense that I put the lecturers, like things, what they're saying together, but also to maintain that, there are these questions happening and to ensure that the questions are also linked with the answers. So in that case, you want to think about, how do I do my chunk size and chunk overlap so that you can touch on both of those concepts. Okay, so these are just 3 examples of what your data may look like that may affect your chunking size. If you have conversational data, you probably want short chunks. Your overlap isn't too important. Character splitters probably are. Documentation data, character splitters might be important, but you really want to think about chunk size and chunk overlap. And lectures, you really want to think about chunk size, chunk overlap, and maybe even character splitters in order to ensure that all of the information is routed correctly.
Right. So I'm going to end the poll now. Just so we kind of get to see it. So 99 people participated, which tells you something about the attendance. It's always fun to see amazing people come from all over the world. And, just a bit about the results. So 60 people, which is 61%, are doing RAGs. Summarization is the main use case for 9 folks, 7 folks with content generation. Search, which we were kind of even debating if we should put in here or not, is 10 people, and other, which is, there's always a long tail with so many different things that have to do with LLMs, or, of course, including complex pipelines that lead to classification by others. And of course, it was built in a way where you kind of have to choose one, right? So it's you can never tell the full story, but it's always interesting to see. And we'll do another poll kind of later on in the event.
Cool. So now we're going to look through some chunking examples. I just did this with LangChain recently. And this is just a picture of all of the different chunking examples we're going to look at. And in a second, I'm going to walk through them one by one. So the chunking examples here are mainly looking at chunk size and chunk overlap. And I've used powers of 2 for chunk size. I've done 32, 64, 128, 256, and 512. For overlap, I've done 4, 8, 16, 32, 64. I used a character splitter with this, and my character splitter that I chose to split on was 2 new lines. And that was because the way the document was formatted was 2 new lines to split the sections. And this is a document about the engineering levels from, junior engineer all the way up to distinguished engineer. So let's take a look at some of these examples. So 32-4, where 32 is your chunk size and 4 is your chunk overlap. This is pretty much completely useless. There's nothing here that's helpful at all. The question that we asked was about, what makes a distinguished engineer? Here, we're clearly seeing that it's pulling out distinguished engineer, 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 but otherwise and completely useless to you. Okay, so what about 64-8? Now we're going to see something that's more like a complete sentence. The first thing that gets reported is engineer, also completely useless. Accomplishments while working as an engineer, perhaps related to distinguish accomplishments and engineer. And then the third sentence, we actually get something useful. Werner Vogel, CTO of Amazon, is a distinguished engineer. So now you have an example of somebody who is a distinguished engineer. So here you have something that is starting to look like something that could be useful to you. Okay, so 64-8, not super useful. What about 128-16? So 128-16, we're going to see that there's actually some useful content out here. Has achieved noteworthy technical professional accomplishments while working as an engineer, provides solid technical leadership beyond the company. It pulls Werner Vogels again. Everything on the senior staff engineer list, plus generally 15 to 20 years of experience. So we'll see that some of these things are what makes a distinguished engineer, but you'll see the second one here, senior software engineer, not super useful. But at 128, we can actually say, hey, we can use this. We can work with this chunk size. We can pull this stuff, and we can actually put this into an app, basically.
Yeah, I just want to kind of comment here. I saw these also when we were kind of doing the prep before, and I got to see these. I think what's really, really interesting, in this context is to break something, to show where it doesn't work well. You always learn a lot more about kind of how it works and how you can kind of, but when you understand how you can mess it up, you kind of understand a bit more about the engineering aspect. So I think seeing how this amazing technology with all the same theory, right, and all these cool kind of graphs of connecting between dots and an embedding space or whatever, it all sounds great. But then you can really, if you mess up the bare metal kind of aspect of it, and you're choosing the wrong chunks, the 32 and 4 example is the best for me, then it all becomes nonsense, right? And I think definitely a lot of the kind of state-of-the-art neural networks that we know today went through different phases, and each component there you had to kind of figure out how not to mess anything up. And obviously here there are just 2 parameters, right? So it's much easier to kind of find something that makes sense. But first of all, even within this space, and it's definitely worth playing with. And also, it's just amazing to see how you can potentially mess up your whole pipeline if you don't chunk a bit and actually look at the text, right? Like if someone just chooses some sort of default or changes it and it doesn't check that it's suitable for their use case, they might say, we checked RAG and it doesn't work, or we worked with a vector database and it didn't work. Where really there's just a problem at the bare metal or the bare metal layer with some very low level definitions.
Yeah, and not just chunking, but we'll also see that with the embeddings as well. Or I'll touch on an example with that when I talk about the embeddings. So now we look at what is the next level from 128-16, what's 256-32 look like. Now we're starting to see these are a little bit longer, and actually you'll see that the third and the fourth one are actually almost the same. The third one is pulled from the distinguished engineer, the fourth one is pulled from senior staff, but you'll see that the wording is almost the same on these, and that's why they're getting very similar scores. You'll also see that this first score this time, it is actually pulling a good chunk of what makes a distinguished engineer. And here we're seeing that you're not getting the full picture, you're not getting the full section, but you're starting to get a little bit of maybe too much context, maybe not very useful context, and you're going to have to start processing these contexts as you use them. Okay, so for the next one, we move to the 512-64, and we actually see that the first response here is actually the entire section of in the document is the entire section of what makes a distinguished engineer. And you'll see that there's a lot of overlap here between this and 128, and we're pulling a lot of the same points. And so what I want to basically get across with this section is your chunking strategy isn't just dependent on what your data looks like, but it also depends on what you need from it. Because if you want to pull individual things one by one, and you want to check your list one by one, then you maybe want to go with the 128 option. But if you want the entire chunk at the same time, because that's the format that you expect it in, then maybe you want to go with the 512 option. So it's not just what your data looks like, but it's also what you need from it in your application. Okay, so now let's look at embeddings.
All right, so just we got a couple of questions, and I'm reminding questions shouldn't be done here; they should be in the Discord. But I'll still give a couple of them. So a couple of them are how do you recommended libraries and packages for automating the chunking process. I have a guess what they'll answer, but I think it's worth hearing it from you.
Sure, yes. So LangChain and Llama Index, very good for this. There's also a couple other ones that are probably less well known. Semantic Kernel, Haystack, and LLMware. These are 5 kind of LLM RAG orchestration kind of tools right now that I've been working with. And they all make it pretty easy. They all include ways that you can do the chunk size and the chunk overlap and the character splitters. They're all in it. It just the use case for you will depend on how much customization you need and what kind of native data types and abstractions that you like.
Okay, great. So another question that I'll give the initial answer, but feel free. So there's a question here. Do the chunking strategies affect the compute cost? So my answer before you dive in is, yeah, I mean, I think that's a second order question. First, solve your problem. It's hard enough to solve your problem. I would not look at the diff of anything that has to do with costs and then say, okay, that's a good reason to chunk differently. Yeah, I'm sure there's some effect somewhere, but I think it's so minor compared to solving your use case and compared to the alternative costs. But I'd love to hear your thoughts about that.
Yeah, I mean, you're completely right, Philip. You first want to solve your use case, and then you want to go into cost optimization. So I think the primary ways that chunking is going to affect your cost stuff is basically when you do your overlap. If you have a lot of overlap between sections, you're just going to incur more memory in your chunked data versus your original data, and then the compute is just because you're sending more data to compute. But other than that, like, as you said, Philip, like really solve your problem before you even think about cost optimization.
Okay, so there are another 2 questions combined. One of them coming from the Discord is do you experiment with chunking size in like a managed way, where saving the results of the experiments and et cetera, et cetera. So I think that's all. I think that all leads also to version to maintaining versions also of the embeddings or of the chunks embeddings, and not only of the other that. And then of course you can use a standard system for experiment management like MLflow weights and biases, and some of the newer ones, TrueLens. I think there are a couple of ones that have to do with this, but that's I think the first part of the question. Another one is they asked about can you chunk semantically, like not only by a character, but by using something that has to do with the meaning or some sort of network. So I'd love to hear your thoughts on both of those.
Okay, so let me see. So the first one, the second one, can you use chunk semantically? The answer is yes. It is a little more complex because you will have to use a model in order to understand the semantics. And so you'll have to be able to throw in your ML model there to find where you should be semantically chunking. Unless you have a preset set of vector embeddings and you are vectorizing and getting the embeddings of your chunks as you go, then maybe, I guess, yeah, still you need a machine learning model for this. Basically, the answer is yes, but it's a lot more complicated. And the first question, what was the first question again?
About managing it has to do with experiment.
Yes, managing the experimentation stuff. Yes, I haven't seen any real anything that I would say is this is the way that you should be doing it. The way that I did it, or the way that I do it in this one, is simply just okay, hey, we're gonna test these parameters, and then we're gonna get our results, and then we're gonna save our results, and we're gonna map them to the parameters. It's a very simple, very hacky kind of way. If you want to do it in production, then yes, you will probably want a more productionized way to work with that. But it's not really something that I do a lot. So
right, but I just want to say something just from the aspect of evaluation and so forth. You need to have a good way to understand what's better. That's hard. We'll have a dedicated session about evaluation, but just what you really care about is the end output of the entire system. So this has to do both with chunking and with embeddings. So there you can do some sort of mini experiments in the middle But I think you need a mechanism for like, golden set, understanding what's the score, annotations, and so forth. And then you can say, okay, the first three versions I was using, I was using this vector database with this and this kind of chunk method. Someone just wrote here that they've been using Spacey to do the chunking. So if you're using Spacey for chunking with this, and then I tried another chunking strategy, you need to have a different version for each vector database, which does require work, resources, whatever. But then you can isolate like what's working better, what isn't, in a systematic way. Otherwise, it is mini experiments, which I think are definitely useful and better than nothing. But I think that's like, if you want to have a significant experiment that's comparing, chunking by sentence or by paragraph for the entire pipeline, that's probably the way you have to go.
Yeah. Okay. Can I get into this embeddings part now?
Yeah, you can go to the next part. There are more questions, but I'll balance with trying to not have a very, very long event. So
all right. Okay, cool. So embeddings, the main thing with embeddings is there's three things we're going to cover here, which is picking a model, deciding what you should be embedding, and then we're going to talk a little bit about metadata. So here's some examples of models you can use for embeddings. These are company logos, basically, or tool logos, right? So you got Hugging Face. Sentence Transformers is really good for low-dimensional embeddings that work decently well and is basically free to you except for your local compute cost. OpenAI, these are the 1536 dimensional embeddings. These are very good semantically. But the cost is quite a bit higher than pretty much anything else on this list. And also, you may not need actually that level of granularity in your dimensionality. You can most of the time, the 1536 is probably overkill unless you need something very, very, very specific. AI Blocks provides a series of open source models that are also on Hugging Face. This is also the company that makes LLMware, one of those LangChain, Llama Index type things. Below AI Blocks, I have Anthropic, which makes Claude. As you know, Claude recently announced their 100K context windows or whatever. Claude also provides some embeddings, a way to embed your models. And then PyTorch. PyTorch is something that I use mainly for when I'm working with images. If I want to get the image embeddings, I would use PyTorch because it's just easier. And then Llama 2 from Meta is something that came out recently. Very popular, very powerful model. And one thing I want to point out here is that, yes, you can use LLMs as your embeddings models, but you do not need to use LLMs as your embeddings models. And these two things are separate, and you should not think of them as the same thing. Okay, so let's look at these very simple levels of embedding strategies. So number one is you just embed your chunks directly. I think this is pretty straightforward. Pretty much take your chunk, embed it, call it a day. Level two is you do this thing where you're embedding either subchunks or super chunks. And so this is something that the Llama Index people will call small to big or big to small. And essentially what this is used for is if you want to save an entire paragraph and only embed part of the one sentence at a time, what this allows you to do is this allows you to pull the paragraph with just one of the sentences. So you get more of the context without having to do the embeddings on the context, but you get a more specific embedding. And the other way around is that you save the embedding for the entire paragraph and you pull specific sentences based on some metadata, which is kind of number three, incorporating chunking and non-chunking metadata. And so what that allows you to do is essentially search for a broader semantic meaning and pull more specific data about it. And then, as I was saying, the last one is incorporating chunking and non-chunking metadata. So depending on what your use case is, you may need different information and you may need to filter on different information. And that's where this kind of comes in. So I just want to give some examples of what is chunking and what is non-chunking metadata. So chunking metadata includes things like paragraph position. So perhaps for your sentence to paragraph one, where in the paragraph is it? Or where in the document is your paragraph? Maybe the section header. What is the section header titled in your document? The larger paragraph. Like what is the larger paragraph that you have that encases your chunk? And then sentence number. Perhaps you want to know if maybe you have something that's like numbered and you want to know where in this document that sentence comes from. And then you have some non-chunking metadata. And non-chunking metadata is metadata that is not related to the way you chunk it. And so this includes things like the author, the publisher, the organization. Perhaps you have role-based access control, who's allowed to access it, things like that, things that just aren't related to the chunking approach. Okay, and so the takeaway from this section is basically your embedding strategy depends on your accuracy, your cost, and your use case needs. Now we're going to go to vector databases.
So wait, just 1 second. We have a bunch of questions that came up before that have to do a lot with the chunking and so forth. I think maybe I'll just I'm putting together a lot of different phrases, but I think a lot of people here are shocked for understanding like how not clean the chunking is, right? Yeah, so I'll give my initial intuition for this, and then I'd love for you to kind of dive into this. I think the idea that why do you need an overlap, right? Because sometimes you might catch the beginning of a sentence or a word, and then you catch it again because you want to catch the whole sentences. So I'll just say from what I know, but I definitely love from your expertise, and you deal with this a lot more than I do, of course. Then, GPT 3.5 or whatever the parallel you're working with is, can work pretty well with some dirt at the beginning or at the end, like some extra characters or some extra sentence. Like of course it's better not to give it, but it doesn't like kill what you're working on, and it's understood. And you could also, especially if you have some custom instructions or prompts, you can also add something that talks about how to deal with them over there. And that's why I think that's part of the reason why an overlap is interesting. And everything here that's related to using semantic, breaking up based on some sort of machine learning model, etc. It is a possibility, but I don't think it's so widespread yet. It might become like the best practice soon, but I think just because there's like some sort of not 100% solution, but some like 75% solution, which is just saying, okay, just feed it in a bit more dirty, and the models are powerful enough to overcome it. And that's why no one tried to solve something in a much, much more elegant way. That's my take on the repeated questions that have to do with this topic. But Yujian, I think your take here is probably a lot more interesting than mine.
Wait, what is the question about like the
there are a lot of questions about how does it make sense to just cut according to characters, and why do you need a character overlap and this and that.
Oh, okay, yes. So I'm gonna go back a little bit more here. Chunk size, chunk overlap, and character splitters. And so it is kind of strange to be like, yes, 512 characters, we're going to cut every 512 characters, we're going to overlap every 64 characters. That is a very rigid approach to this, and that's why people have come up with this idea of using, well, as someone mentioned earlier, the semantic chunking, but also to use character splitters to be like, okay, well, we know that in this document, maybe 2 new lines is a section split. And so you'll see that actually, these are not actually 512 characters. If you go and you actually check how many characters they are, they're actually somewhere in 300 something, 400 something range. They're not actually 512 characters. And the reason for that is because we put these character splitters in there. And so, yes, it is kind of a strange thing to do. And you can basically find a way around that. But from time to time, if you don't use character splitters, if you just want to do it naively, you do want to make sure that you're chunking and that you're keeping these chunks, chunk overlaps over there so that you maintain that context between different chunks. Even if you are using character splitters, you probably want to maintain some context between your chunks. So it's good to have chunk overlap so that like, oh, this section actually overlaps with this section. And so if you need, what you can do is actually you can pull both sections given one section if you need it.
All right. So there have been some really interesting new questions, but let's let you go to the last part and see if we have any more time for questions at the end.
All right. I know we're on a few minutes here, so I'm going to try to speed through this. So the basic idea of this section is vector databases provide the ability to inject your data via semantic similarity. And the considerations when you are working with a vector database or picking a vector database include scale, performance, and flexibility. So first, I'm going to cover semantic similarity really quick. Basically, what it allows you to do what vectors allow you to do is they allow you to compare things that are not numbers, and they allow you to do math on things that are not numbers, things like words. And so in this example, I have this queen minus woman plus man equals king. This is a very, very popular, very, very well-known image. This is from a paper from Suter et al. And basically what this shows is that if you take queen, which is 0.3 comma 0.9, and you subtract woman, which is 0.3 comma 0.4, you'll end up with a word like 0, or you'll end up with the vector 0 comma 0.5. And if you add man, which is 0.5 comma 0.2, you end up at 0.5 comma 0.7, which happens to correspond to king. There are a few things I want to point out here. So number one, no one uses two-dimensional vectors in real life. Don't do this. Number two is no one does Manhattan distance in real life. Don't do that. It's entirely like it's not very useful. Number three, so you'll see that queen and woman and king and man have the same value on the first axis. That means that these words mean the same thing on that dimension from the data set that they were trained on. It does not tell us what the dimension means. So queen and woman, this 0.3 does not necessarily mean this first axis corresponds to gender. It just simply, it could be like that words with 5 characters have a value of 0.3 on this axis. What I want to really point out here is just these dimensions are abstract and do not necessarily correspond to any meaning in our real life. Okay, so where do vectors come from? Where do you get these vectors, right? So you take your knowledge base, you take whatever data you have, and you put it into some sort of deep learning model, like the ones I showed before from Hugging Face or AI blocks or whatever. And you cut off the last layer, and you get the output from the second to last layer, and that's your vector embedding. So why the output from the second to last layer? Because as you feed data through a machine learning network, through a machine learning model, each layer of the model learns something new. And so at the last layer, you have basically everything the model understands about your data without having it make a prediction, which is where the last layer is. So that's why we take the vectors from the second to last layer. And then you store that in like Zilliz or Milvus, and you do similarity search. This is what a block, like an entry or a row, whatever you want to think about this. This is an entry into the vector database. This is what it looks like. You can have some ID. You can make up your ID. Here you can see I made up my ID. And then you have the embeddings. And these are the two most important fields. Is one, you have an ID that you can pull by, and an embeddings that you can compare. And then you can have metadata. As we were talking about, I have a lot of non-chunking metadata in here: date, reading time, subtitle, publication, et cetera, et cetera, et cetera. So this is what a entry into the vector database looks like: ID, embedding, metadata. Okay, so why would you use a vector database as opposed to just a NoSQL database or a SQL database? I'm not going to read this entire slide, but you can take a picture if you would like, and I believe slides will be available. So basically, the thought is that vector operations are too computationally intensive for traditional database infrastructures. And the reason why this is because if you think about the way that SQL databases and NoSQL databases are designed, they're designed in such a way that you are looking for a key value pair, a key to key match, an exact match every time. So there's no design decisions that allow for highly computationally expensive designs. Instead, what it's looking for is, how do I most quickly scrape through this entire thing and find the right keys? Very different architecture, very different design. Okay, why not a vector search library? So this includes things like Face or HNSW or whatever. Vector search libraries are great. Milvus implements 9 of them. You can use any one you want, and this is where it comes back to flexibility. If you want something that's flexible, you probably want to use a vector database like Milvus, where you can just slap whatever vector search library you need on top of it. Vector search libraries don't have the infrastructure underneath to help you scale, deploy, and manage your apps in production. So that's why you would use something like Milvus or Zilliz. So I mentioned this earlier. We are the only distributed system cloud-native vector database. And essentially what that means to us is, essentially the reason why we do this is because we are aimed at billion-plus scale. We want to be supporting the big enterprises that are doing billions and billions of vectors. For example, Alibaba has 5 trillion vectors, and our goal is to be able to support that in the next couple of years. So the reason why we've built out this thing with scale is basically because about 80% of the data in the world is unstructured data. As I mentioned at the beginning of my talk, Zilliz is a company that's based on dealing with unstructured data. And that means that there's 4 times more data out there than we're currently even touching, much less processing. And so we believe that the most difficult problem to solve in this unstructured database, in this unstructured data space, is scale and how you work with data at scale. And so that's why Milvus and Zilliz is built with this distributed system native backend in mind. So our differentiation, as I said earlier, cloud native, distributed system architecture. true separation of concerns, there are three concerns when it comes to search: queries, indexing, and data ingestion. And so we have these actually truly separated out so you can scale them up more flexibly. And then we have a scalable index creation strategy by creating indexes over small segments. Defaults at 512. It doesn't have to be 512. You can use whatever custom you want, but smaller segments so that as you scale, you don't have to re-index your data. And re-indexing is very, very computationally expensive. And that's why we came and approached this with a strategy of, if you're using Milvus, the goal is that you should never have to re-index your data. Okay, so the takeaway from this section is basically vector databases are purpose-built to handle indexing, storing, and querying vector data, and Milvus and Zilliz are specifically designed for high-performance and billion-plus scale use cases. And finally, I've got some resources for you guys. One is an open source benchmarking tool. Download it, bring your own data, check it out. Obviously, it is, we made this tool, but it is open source, so we want you to go use it and check it out yourself. Don't just take our word for it. And then on this other side, there's an advanced hands-on LLM/RAG app building tutorial. This teaches you how to build a RAG app that is somewhat reflective of what an enterprise might actually need, because it separates out many of the documents and routes them based on that separation. So I think I've pretty much come to the end of this session, so we can take Q&A.
Yeah, so I'll give a couple of questions. There were a lot of interesting questions. I didn't manage to get to everything. I think Yujian, I think both of us should, but probably more you, should go over the questions in the Discord and answer them kind of in offline. Feel free to also reach out and so forth. First question that has to do with quite a few questions that I think I'll give an initial answer to. There were a lot of questions about how to kind of evaluate what's better, given that you have a couple of hypotheses and so forth. So in my opinion, the first step for anything that has to do with evaluation is creating the parallel of a test set, which you don't really have in generative, which is golden set. Start off by sitting with everyone that's relevant, deciding on the samples that you're going to be used for evaluation. And then whatever you're experimenting with, you want to circle back to those same samples. Now, those samples can change over time. Once your use case becomes more, fine-tuned, or you understand more about the users, you get production data, you can switch those. But I've seen in many, many cases working without a golden set or evaluation set or whatever. And then that does include some manual work. This is a lot of our focus at DeepCheck, so feel free to reach out just for advice that has to do with it. But I think, and any question that has to do, how do you evaluate X and Y and Z? There are so many ways to go wrong, especially when you're doing like an evaluation of a micro part of the pipeline, right? Because just if we go back to the chunking, which I think we can see there's a lot of interest here, by the way, just a point of thought for your future lectures, whatever you're building. I think it's clear that there was a lot of interest there. So you might think some chunking strategy is better for some kind of micro metric that you're looking at, but then in the entire pipeline, it could be better. So I think that's one question that's coming up a lot. So let me give you, let's start with one other question. So 1 second. So there's a question here about e-commerce use case where the product data is hierarchical. How do I get that right? Where there's a hierarchy within the product data. So how would you think about embedding something like that where it's not sequential, but it's built with some sort of hierarchy?
Yeah, so I would say that if you have that kind of hierarchical data, what you actually want to do is you want to build a graph on top of it. Yes, you can do the embeddings, but unless your semantic embeddings are... So what you probably want to do is you probably want to build a graph, and inside the graph, each node of the graph may correspond to different vector indices, because the hierarchical relationship between the data is primarily what you want to preserve semantically is the relationship between that data. And then you want to look into, let's say, maybe the product description, then you may want to use vectors, vector databases and embeddings and chunkings and stuff like that to work with that. But I think, the primary concern for being able to work with this hierarchical data is that you create some sort of graph that embeds those relationships.
All right, great. Another question. So there was a question here that was specific in this case for finance, but about asking about which public embeddings are suitable for different use cases, given the specific example of finance. So I'll just say for one word, I saw the different models that you put in the slide. I just want to add one, it's not as well known, but I've seen success in a few different use cases of flag embedding. It's open source. So it's I think from a Chinese origin. I think it's I've seen it in specific use cases outperforming some of the more well-known ones. So I would look at the flag embedding just in like a generic way for I think it's mainly English and Chinese. But then maybe if you have any other generic tips or also tips that have to do with with specifically for finance industry. I'm guessing there's a lot going on in the finance industry, right? You could have text, numbers, whatever, but maybe say something about that.
Yes. So actually, the company, one of the models I put up was this company called AI Blocks. They are actually specifically focused on fintech. And so they have generalized models, but they also have very focused fintech models. And so they build this thing called LLMware, LLMWARE. You can check that out specifically for fintech. That's actually very useful. Otherwise, I would say you probably want to use one of the generalized models. You probably want to use one of the Hugging Face models. And this is where fine tuning is useful. Is you can fine tune these kind of smaller models, which are trained on smaller data sets, and you can fine tune them to be more leaning towards the type of financial kind of data that you need by giving them financial data when you fine tune them.
Okay, so there were another couple of questions about experiment management. I'm not going to answer them just because we already talked about them a bit. And okay, so there was another question that I'm not sure I know how to answer Oh, you know what? Actually, we have one more poll. I'm launching the poll as we talk about what phase are you in the LLM development stage, and we'll take the question as we go. So I'd love to answer, basically, are you conceptualization or design, development and testing, production and deployment, or optimization and scaling? Okay, so we'll take that poll and we'll publish the results soon. Let's take another question. So do strategies change if we want to work with character embeddings? So
Embeddings.
Yeah, so I'm not sure what that means, to be honest, but I think character embeddings, I'm not sure what language it means for, but I think maybe it's worth mentioning the chunkings that we're talking about. You're embedding the chunk, right? You're taking whatever chunk, then you're embedding the chunk. After you retrieve it, it's almost like giving that chunk a name, right? So, and then you're just calling it by whatever you use. Doesn't matter if you've been jumping around the room on a pogo stick to use it, or you have a secret machine or some kind of prophet closing their eyes and wishing in the box. Whatever they do, they take their hand in, and then they take out the text, right? They're taking out the text that was originally there, whether it's a paragraph or a character or a sentence, and it's combined. This, you have to say something. You mentioned that you have metadata kind of connected. So you can also bring back the paragraph together with the metadata about it, right? So maybe, just, feel free to add anything about that for the different, the different approaches.
Sure. I don't know what character embeddings are either. I've never heard this term. So I can't really say anything about that. But if you want to have more fine-grained embeddings, then yes, you can do this kind of big to small thing. Instead of doing sentence to paragraph, you could do words to sentences. You could do, look, if you want to embed character like A, B, C, D, that's fine. You can also, map those to words or map words to those. It's really the general strategy of mapping these different kind of embeddings to the actual text is still applicable. But I don't know what character embeddings are. Maybe you're working with I guess if you're working with a character-based language like Chinese or Arabic or Korean or something like that, then maybe it makes more sense. But in terms of English, I haven't seen or heard this done.
Yeah. All right. So we're wrapping it up here. Just last thing I want to point your attention to. So there's the poll results are out. So 38% here are in conceptualization and design. Development and testing is maybe evaluating different versions is 40%, 18% in production and deployment, which is pretty high, I think. And optimization and scaling. I'm sure this will all be, a year from now, the numbers will all be different, and things are moving pretty fast, and a lot of the tooling and concepts and so forth are enabling to work faster. But it's interesting to see. Anyway, I just want to remind everyone, first of all, thank you so much, Yujian, for this session. I know I learned a lot, and even though it's kind of concepts and you can kind of explain about them, it's really different to dive in. And I just want to remind a couple of things. First of all, we're aiming to have every week or two, basically, to have some sort of event. Next event is on the 16th in 10 days. Sign up. I sent the link earlier. It's also on the LinkedIn page of LLMOps.Space. I also want to remind about any questions, interactions, and so forth. Feel free to either direct message Yujian or myself, and also we'll hopefully go over the questions and answer them. Some of them were answered live, maybe not, but we'll try to do our best. And I think that's it for now. Any potential speakers, proposals for other events and so forth, then again, you know where to find us. And have a great morning, afternoon, or evening, depending on your time zone.